Welcome back, everyone, to another deep learning video. Today, we will be continuing where we left off yesterday. If you haven't seen that video already, go check it out. We have covered what do you mean by deep learning. We have covered a few things which you can do by deep learning. We've also interacted with a few applications which use deep learning. We've seen image recognition yesterday. We've seen audio recognition yesterday. A lot of stuff. We didn't go into the nitty gritty of any of them. So if you guys didn't check it out yet, you guys can go check it out. I'll leave a link to it in the description as well. Or you can check the whole playlist on my channel. So, what are we doing today? We have a few things in our mind which I want to cover today. But firstly, I would like to discuss about a term about deep learning. So, you guys might have heard of machine learning, right? Before you go into deep learning, I think most of you know what machine learning is. So, today I think we'll take a look at where machine learning is failing and why we had to come up with deep learning procedures. So, yeah, if you guys are excited about these kind of videos or these kind of boot camps, make sure you go smash that like button. I have a lot of videos coming up very soon, and I think we'll go and uncover the mysteries of deep learning in ways nobody has ever done before. So if you are excited, make sure you go smash that like button, and we'll go start the video now. So first off, we'll take a look at what is machine learning. Now, a lot of people might already know what machine learning is, but for the people who don't know what machine learning is like teaching a computer with examples. I'll give you a simple example. Let's say you have the same example I've taken yesterday, which is the spam email classification. So let's say you have an email and you want to classify whether it is a spam or it is not a spam. How would you do this? How would you go ahead with do this? If you try to make rule based approaches, it would simply not work, because we've discussed in the last video as well that simply using rule based ones might make sure that you will get some of the emails right, but most of them you will not be able to do it, because if the scammer or spammer tries to find some new techniques to try and write their emails, your rule based ones will be neglected. So that is the reason rule based ones don't exist. So what is machine learning? Machine learning is basically teaching your computer with several examples of spam emails. So let's say I have like 1,000 spam emails and 2,000 non-spam emails, something like that. And I'll show my computer these examples. And when a new spam email comes to my inbox, my machine has already learned what a spam email will look like, and it will be easily able to predict whether the given email right now is a spam email or not. So that is basically how machine learning works. But you might ask me, like, did we see this yesterday? Didn't we see this yesterday? And didn't you give this example as one of the examples for deep learning, right? So yeah, that is right. I did give the same example for deep learning. That's because deep learning is a type of machine learning. Okay. The main thing which separates deep learning from machine learning is artificial neural networks, or in short form, they're called ANNs. I'll just write them down here. They are called artificial neural network. Now, these are the only things which separate deep learning from machine learning, and these are inspired by how our brain works. Now, these neural networks will have a lot of layers in there. So, if you haven't seen my previous video, I highly recommend you go check it out. I gave a very cool example so that you'll easily be able to understand. So, yeah, the neural networks simply, if you work with them, you are doing deep learning. In machine learning, there's a lot of models. So deep learning and machine learning, the only difference is you'll work with neural networks in deep learning. So yeah, I think that part is clear, everybody. And we'll take a look at where this machine learning model might face some struggles. Okay, so this machine learning model might face some struggles in some way. Okay, so let's take a few examples. If you have if you have to classify how a flower looks based on the petal length, petal width, sepal length, and etc. and you have to classify them into different species. Now, you can do that by just taking a look at the type of data which you have, and you'll be able to classify it easily. But this is fine. This is fine because the data which you have for classifying these flowers might be very small. You have a very tiny amount of data, and through that, you can train a machine learning model very easily. And the data which you need here is should be structured as well. So you have seen pandas. You've seen how you can deal with structured data in pandas. If you haven't, I made a video about pandas. You can go check it out. It'll be on the top right. So you guys can check that out. But data is structured, right? You have a lot of tabular data in machine learning. You have a lot of data which is structured, and usually you have things. Usually you have things which requires manual output. So let's say you have a very structured data. The structured data requires a lot of manpower in order to uh, classify different lengths and different widths uh, into separate species. So you need some person in the background trying to make this data. So in these cases, you are able to design this kind of machine learning classifier very easily. But when if you come and think about it, uh, usually in real world the data is very large. Okay, it doesn't usually have like 400 or 500 rows. It is usually in some billions and millions of data. Okay, and data is usually not structured as well. So you can have a lot of image data. You can have a lot of big text data. You can have videos for data. You can have speech for data. So all of these data you have. Okay, and traditional machine learning will not be able to directly understand these images or these text or these videos or these audio files. So we would need something called as a feature engineering. What is this feature engineering? This feature engineering where humans will manually decide what the model will focus on. What should the model focus on? If we take an example of an image, you can convert this image into several, you know, columns in a data set, uh, having the intensity of color for each having the intensity of color for each pixel, and then you will easily be able to train a machine learning model on that. So to convert this image from this to this, you need a human convention in between. So that part is called as feature engineering. So like to detect like a cat in a photo or to detect some edges. So the human needs to extract the edges, shapes, eyes, fur patterns, and then he would need to create a data set for it. Now that's a lot of work and it doesn't guarantee perfection as well. So machine learning will usually struggle with these kind of inputs. So overall, if the problem is very simple and data is small, you can use machine learning techniques and it would be very easy. But if the problem is complex and the data is very huge, machine learning will usually fail in these cases. Now that's where deep learning comes in. Deep learning is super powerful in the areas where machine learning struggles. So you don't need to have no humans to manually suggest what the model should and should not learn, and you just can think of deep learning in such a way that if you have a deep learning model here, you give it input thousands and lakhs of images and you'll just get the output as whatever you want the output. So you don't need humans to manually design what to specify, what you should learn, what you shouldn't learn. For example, you can give the deep learning model thousands of cat photos, and it can easily detect whiskers, ears, shapes, all by itself. So that is one advantage of deep learning. The second advantage is deep learning is more powered by GPUs rather than the CPUs. This is because each layer or each stuff are trained specifically to run in an optimal way using special hardware like GPUs and CPUs. Now, deep learning is also very good with images. It is very good with text. It is very good with videos, audio, etc. All of these deep learning can handle it very easily. Unlike machine learning, we had to apply feature engineering to these stuff in order to make them suitable for a particular algorithm. So I'll give a few examples where deep learning is used. You might have seen Face ID on phones, face recognition, Face ID on phones. You can just directly open your mobile phone by just taking a uh, showing your face to the phone. Or you have self-driving cars. A lot of people might be very interested in self-driving cars. You have Netflix recommendations. Okay, whenever you open Netflix, you might see some recommendations, and so on. You have voice assistants, Siri, Alexa, Google Assistant, so on. So because deep learning can capture complex patterns that are very opposite to what machine learning is trying to do, it is more preferable. Okay, so here I have this beautiful table, which conveniently shows us a lot of stuff. So the in machine learning, the data we need is very small. In deep learning, the data we need is very huge, and feature extraction in machine learning, you have to do manual feature extraction, but in deep learning, the model will automatically know what features it should learn, what features it should not learn. And accuracy, in terms of accuracy, machine learning usually performs in a low to medium range, but in terms of deep learning, it performs in a higher range. And when it comes to the hardware required in machine learning, you can run a lot of machine learning models on the CPU very quickly. But deep learning is specifically designed to run on the GPUs and the TPUs so that it provides good throughput. And finally, machine learning is good at simple and structured data, and deep learning is very good at images, speech, and text. So I hope you have a clearer understanding of what we saw today. Uh, and again, I'm not saying that machine learning is not at all important. Machine learning is important. It serves as a base to deep learning. But I just wanted to I just wanted to make this video to clarify why we prefer deep learning than with machine learning. But it would be very helpful if you do know machine learning, because a lot of things which you learned in machine learning, concepts which you learned in machine learning, like overfitting, underfitting, or different terminology which you learn, will you often see them happening in deep learning as well. So that is pretty much it for this video. And if you found this video helpful, make sure you go ahead, smash that like button, and let me know that you like this series. What way you want this series to steer on, and a lot of videos are coming. So until then, keep learning, and I'll see you all in the next one.